They deploy the smoothness terms and the end result was RBF functions. So you need not to regularize further. So if you want the existing code to use, just supply lambda equals to 0 and do not cross validate for 0 if you are using RBF network function. Make sense? So far so good? So regularization is not required. But this is a document.
Yeah.
Again, we have a training set. Split your training set into two parts. Hold out set, one set is called let's say test out set, test set. Then the rest of the set split them into training set and validation set. Yes? Start with, let's say I take 2 clusters and see what is the test error or the validation error. Then take k is equal to 3. Apply k-means clustering again. Make 3 clusters and repeat the whole process for 3 clusters. Then change k, the value of k to 4. So cross validate over the number of clusters. What should be the number of clusters? To find out the best number of clusters for your data set at hand. मेरी बात समझ में आ रही? दोबारा से देखिए. अब यहाँ पे regularization lambda पे तो हो रही है. So we want to find out what is the best number of clusters we have. सही है? So best number of clusters आपके 1, 2, 3 और intuitively ऐसा लग रहा है जितनी classes हो उतने clusters होने चाहिए. But it turns out that if you allow this number of clusters to vary, other than your performance may change and practically it changes.
Yeah.
So you start from cluster 2, check the performance, then cluster 3, check the performance. When k is equal to 3, you have to recluster everything. So everything's stripped. Then cluster 4, 5, 6, 7, 8, you're done. So the minimum number of clusters, yani ye jo outer loop hai, it starts from 2. What is the maximum number of clusters you should try out? कितने? नहीं आपको तो नहीं पता. चलते जाएं कहाँ पे जाके आप कहेंगे यार इससे ज़्यादा नंबर ऑफ क्लस्टर्स में तो डिवाइड ही नहीं करना चाहिए.
Not more than number of points. Data point is other
उससे बहुत पहले. Divided by 10. It should be 1/10 of the total number of points. Remember आपके जितने clusters होंगे उतने आपके parameters होंगे. Your total number of parameters is equal to k. W1 is 1 parameter, W2 is 2 parameter. Remember you have to estimate W. आपके number of parameters is equal to number of clusters. और मैंने आपको बताया था rule of thumb that your number of parameters it should not be more than 1/10 of your number of data points. Remember that? So you should try to 1/10 of the data points. That's that many clusters. And if the performance is found, then okay. Otherwise, go to SVM or go to logistic regression. Do not stick over there. It is a popular classifier to be with you in your classifiers toolbox. When you apply this classifier, consider this as well. Make sense? Yes?
Yes.
Okay. Now the second thing. So you will find out k using cross validation. That's a painful thing, but you should go with it. Second thing, how to find the best value of R, because when you apply kernels, these are the kernel parameters that are very, very important and you should not carelessly choose those. Yes?
अगर 1/10 clusters तक check करना है, number of clusters.
1/10 of the clusters.
तो maximum performance, maximum clusters क्या है? कैसे?
कोई जरूरी नहीं, पता नहीं.
वहाँ पे ही आनी चाहिए.
नहीं, पता नहीं. Depends on data. Maybe 3 clusters में data बड़ा अच्छा represented था. You forcefully break those and make those more clusters. And वो actually clusters बन. I mean it depends upon data.
तो उसके साथ threshold value नहीं पड़ेगी.
कौन सी?
Okay, इतना है ना.
Validation आपके पास set है.
Okay, so उसका minimum matter वाला पिक.
आपने देखना है कि validation performance किस k की value में सबसे बेहतर आ रही है. Make sense? Okay. Second, in the very first row, एक bad news आपको ये लग सकती है कि यार ये k पे भी cross validate करना तो शायद r पे भी cross validate करना पड़ेगा. No, this is not the case. Actually, the r can be found in a very systematic way, and here is how we do that. So k is given, let's say k is equal to 10, it is given. Let's say k is given. This is the error function that you want to minimize. W1, W2, W, K and R as well. R will depend on the error. This is you want to minimize. This is I varies from 1 to n, J varies from 1 to K, W, J, e raised to the power minus R, xi minus bj squared minus yi, this thing, whole square. That's the error function. Make sense? Yes, no? It turns out कि अगर आप W और R दोनों वेरिएबल देखें, minimizing this to a global minimum is not very straightforward. Make sense? हम करेंगे ये. Again we will move like K-means or chicken-eggs kind of thing. We will first fix R is equal to some value, and once R is fixed, you just have a linear regression to go with. Find out the best W. Make sense? Once those W's are found, use those W's to be fixed and minimize this error function with respect to R. मेरी बात समझ में आ रही? So if W is given, अगर आपको मैं W दे दूँ, W is no longer a variable, it is not a parameter. W भी given है जैसे X given है वैसे B given है, W मैं आपको दे दूँ और आपसे कहूँ कि इस पूरे error function को minimize करें with respect to R, find out the value R that minimizes the error. तो आपको क्या करना चाहिए?
और सर वैल्यू शायद से मिनिमम होगा वो
करंट देखने चाहिए।
No.
लेकिन W भी तो है।
And the reason is W given है।
अच्छा।
R की सारी values try करेंगे, yes, जो minimum है, but there are infinitely many values of R. So what we have done already, take the derivative, put it equal to 0, find the R.
Oh yes.
Yes. वो तो डेरिवेटिव लेंगे तो पता चलेगा क्लोज फॉर्म में आएगा।
Oh yes.
तो पहला तो ये है ना कि इसका डेरिवेटिव लेंगे विद रिस्पेक्ट टू R and find out where the derivative is 0. Make sense? And given W, we can find out the best R given W. अगर मैं आपको W दे दूँ और आपसे कहूँ कौन सा R है जो एरर को मिनिमाइज करेगा, you can find out the best R by finding out the R where the derivative of the error is 0 with respect to R. So no problem. Differentiate this with respect to R, put it equal to 0. Now the problem comes whether R can be found in a closed form way or not. जैसे linear regression हमने देखा था, W was found in a closed form way. In this particular case, R will not be found in a closed form way because of e raised to the power of the variable. It will stay there and separation is not easy. तो जब closed form ना हो तो आपको क्या करना चाहिए? Gradient descent. That's it. So apply gradient descent and find out the best R. Yes? Once you find the R that minimizes the error, now you should re-find the W. Because given R, we can find out the best W that minimizes the error function. Start में आपको R नहीं पता था. Start में you fix some R and with respect to that R, you find out W that minimizes. इस W के लिहाज से there is another R that minimizes further. Now with respect to this R, there is another W that minimizes further. Keep on doing this. This is EM, expectation maximization algorithm. You fix one, you solve for the other. You fix that, you solve for the first one. And you keep on moving that until you converge. Make sense? Yes, no?
So पहले हम अपना बेस्ट जो था हमारा K वो निकाल के रखेंगे, उसके बाद जो W आएगा उसके ऊपर
No, पहले K best नहीं निकाल के रखेंगे. So this is how we go. This is the outer loop. This is the outer loop of cross validation for K is equal to 2 to n by 10. That's it. So यहाँ पर ये वैल्यू K की आएगी ना, ये outer loop है, ठीक है जी? ये क्रॉस वैलिडेशन वाला लूप है, ये उसके अंदर है. जब K की वैल्यू 2 थी, what is the best W and R? तो आप EM लगाएं. पहले तो क्लस्टरिंग करें डेटा की, 2 क्लस्टर्स में 2 B1 B2 आ जाएंगे. फिर R को फिक्स करें, W निकालें. अभी K फिक्स है. R को फिक्स करें, W निकालें, W को फिक्स करें, R ग्रेडियंट डिसेंट से निकालें, keep on moving and you find out best W in R. Make sense? अब वैलिडेशन में जाकर परफॉर्मेंस टेस्ट करें. बाय द वे टेस्ट पॉइंट हम क्या करेंगे? जब टेस्ट पॉइंट आएगा क्या करेंगे? R भी आपको पता है, B1 B2 भी पता है. जब नया पॉइंट आएगा उसको ट्रांसफॉर्म करें नए फीचर्स में और जैसे लीनियर रिग्रेशन क्लासिफाई करते हैं क्लासिफाई करें. यस नो? R पता है ना आपको? R पता है? तो नए फीचर्स बना सकते हैं ना. जब नए फीचर्स बन गए अब W भी पता है तो क्लासिफाई कर लेंगे. वही जो F प्रेडिक्ट का फंक्शन है लीनियर रिग्रेशन में. You just have to transform your features to new features. Rest of the story is ट्रेनिंग टाइम पे ये ग्रेडियंट डिसेंट के साथ ट्रेनिंग टाइम पे चलना है. टेस्टिंग टाइम में तो एक आना है, आपको बेस्ट R भी पता होना है, बेस्ट K भी पता होना है, सारा कुछ आपने क्रॉस वैलिडेशन से करते हुए रखा होना है. मेक सेंस? अच्छा.
That's why RBF training का ज़्यादा रखता है और वर्क टाइम कम ही रहता है.
सॉरी?
That's why RBF यूज़ करते हैं तो ट्रेनिंग टाइम ज़्यादा लगता है.
No, this is the cross validation that is taking a lot of time. RBF में जो डॉट प्रोडक्ट आप कंप्यूट कर रहे हैं, this is no longer a big computational thing. और वो जो आप कह रहे हैं कि SVM को कई दफ़ा ज़्यादा टाइम लगता है, किसी लेवल के लिहाज से कई दफ़ा कम टाइम लगता है. That is the quad prob that might be taking a lot of time to converge to open and out. That is not due to kernel. That is kernel के बाद separation find out करना is how much easy.
इसमें भी तो हम sort of वही काम कर रहे हैं. हम एक दफ़ा एक चीज़ को फिक्स करते हैं, दूसरे में निकालते हैं, उसको फिक्स करते हैं, हम करते रहते हैं जब तक कि कन्वर्जन हो जाए.
So that is, I mean, you have to go to the total number of iterations. That is the problem with EM or every algorithm that is iterative. Every algorithm that is iterative. This has nothing to do in particular with RBF kernel. Makes sense? Okay, so for k is equal to 2, you make 2 clusters, then you apply linear regression, then gradient descent, then linear regression, then gradient descent and stuff like that. At the end, you find out the best W's and you find out the best R. Make sense? Using best R and B1, B2, you convert your validation data to the new features and use W to predict. Make sense?
Yes.
And compute the misclassification error, compute the error. Make sense? Then change K to 3, repeat the process and change and find out the best K. Make sense? It turns out that this RBF network, with this a lot of cross validation and stuff, it has a very comparable performance with SVM. And it can handle a lot of data points as in contrast to SVM. If SVM has to handle a lot of data points, there are problems with SVM. The prog take a lot of time and never convert and stuff like that. It is just a linear regression. It is just a linear regression at the end of the day. The training time is a lot fine due to cross validation, and the performance is comparable to SVM practically, not theoretically. And these number of clusters has some relationship with the number of support vectors in SVM. So these are the number of clusters here and the number of support vectors there in SVM. They have a particular relationship that can be established. Make sense? So this is, and by the way, you need not do, I mean, a very hairy kind of cross validation. You need not to go one step further. Let's say K is equal to 1, then the next, then the 2. For example, take jump of 10, 10, 10, or 20, 20, 20 and stuff, and then see around which number of clusters the error is minimized, and then zoom in there. Take a jump, smaller jump, and zoom in. This is called force to find sampling. So पहले आप जब cross validation का पहला phase लें तो बड़े jumps लें. ये मैंने पहले भी बताया था आपको. So you can improve this cross validation, but you have to do cross validation if you are very careful about it, and you should be. Make sense? Yes, no? So this is RBF network classifier. I hope you should have this classifier in your toolbox because of its simplicity. It is simple. It is not very difficult kind of things. I mean, it is linear regression along with the gradient descent just to minimize this.
Yes.
Yes, no?
Yes.
Okay. Yes.
जो हम K means के अंदर rhythm use करते हैं उसका नाम क्या है?
Sorry?
K means के अंदर जो rhythm use करते हैं जो हम यहाँ
EM, expectation maximization.
और ये आउटलायर्स के केस में सही फॉर्म करेगा.
it has comparable performance with SVM. With respect to that, I can say it is somewhat robust to outliers.
या maybe आप outliers उधर K ही में ढूंढ रहे हैं.
K-means में outlier भी शायद handle नहीं हो रहे क्योंकि squared error is there and squared error is very sensitive to outliers. So I really don't know the answer whether it is robust to outliers or not. I have to check it. Actually, you should check it. Make sense? So because of squared error, whenever there is a squared error, I mean, I usually go towards the sensitive to outlier. And there is a squared error in two things. K means apply squared error, linear regression apply squared error. So I think it should be taken into account कि outlier sensitivity इसकी कितनी है. Make sense? Okay. How many lectures do we have? A lot of things to cover, and I want to schedule. I want to skip them. And how many more lectures do we have? From Tuesday onwards, how many lectures do we have? Exactly 8? More than 8? Less than 8? How many? 8 lectures. Sorry? अच्छा. 8 lecture है हमारे पास. Okay, let's schedule the 8 lectures in the following way. In the next lecture, I will cover inshallah PCA, one standard technique to reduce dimensions and use a lot. In the next to next lecture, I will try to cover the supervised dimensionality reduction called the Fisher's linear discriminant that is also used a lot. And there we will stop the classical machine learning. I have more topics to cover. I really love to cover error boost and lagging and stuff, but I guess I should move on towards the new topics that are. And the last 6 lectures will be devoted completely towards deep learning, the advances in machine learning. So I will limit myself to just cover 2 more topics from the classical machine learning, PCA and FPGA. Both are dimensionality reduction techniques. One is supervised, one is non-supervised. And then we will move towards deep learning and spend 6 lectures on neural networks. ठीक है जी? Having said that, I will start uploading from tomorrow your practice questions for your final term exam, and they will be very, very theoretically involved. So you have to start solving the practice file to better